Turn on, turn off, plug in, unplug. Gestures we perform every day whenever we need to. Electric energy, or electricity, is such an integral part of our lives that we forget about it in the end. But just what is electricity? To better understand this phenomenon, we need to think about the world at the atomic level. Air, water, living beings, and physical objects such as electric wires are all made up of tiny atoms. Each atom has a nucleus surrounded by electrons that revolve around it much the way satellites orbit the Earth. The electrons in certain metals, like copper, can easily leave their orbits. These materials are called conductors. What happens when an electron escapes its orbit? The electron simply moves over to the nucleus of another atom. And when electrons move, it produces what we call an electric current. But how can we get electrons to move? Here is a natural magnet. Magnets have a north pole and a south pole. We can see the lines of force in the magnetic field here. When we bring two magnets close together, they can attract or repel each other. There's something between the two of them that allows this movement. That something is the magnetic field. A little like what happens between two magnets, the magnetic field has an effect on electrons. When we wave a magnet over a conductor, such as a copper wire, the magnetic field attracts or repels the electrons. This movement of electrons is electricity. So where does the electricity we use every day come from? Let's follow electricity all the way back to the source, the place it is generated. Electricity comes from the gigantic generating units found in hydroelectric power stations. These generators operate on exactly the same principle as the magnet and the copper wire. Let's see how. A generator has two main components: the rotor and the stator. The rotor contains a series of magnets that we call poles. The stator, for its part, consists of a number of copper bars. To simplify things, let's see what happens with a single magnet and a single copper bar. Simply bringing the magnet close to the copper bar is not enough to produce current. Without movement, there is no electricity. Now let's see what happens if we begin to rotate our magnet. When we rotate the magnet next to the copper bar, the magnetic field causes a movement of electrons, and hence, electricity. Let's go back to our rotor. It creates exactly the same effect as a magnet, except that it is made up of electromagnets. An electromagnet is used when a very powerful magnet is needed. It consists of a metal core placed inside a coil of electric wire. When a current flows through the electric coil, a magnetic field very similar to that of a magnet is created. The main advantage of an electromagnet is that the force of its magnetism can be controlled. The rotor has several electromagnets. They alternately attract and repel the electrons that are in the stator's copper bars. In this way, the generator can power millions of light bulbs. But how can we get such a heavy rotor to rotate? With a motor? No, that would certainly not be very efficient. In Quebec, it is mainly the mechanical force of water that makes rotors rotate. The water hits the blades of the turbine, making it turn. To generate electricity, Hydro-Québec thus uses a renewable energy source. The rotating motion of the turbine drives the shaft as well. And since the rotor is also attached to the shaft, it rotates around the stator and makes the electrons move. But these moving electrons don't travel all the way from the generating station to your home. In actual fact, the electrons move through wires in a domino effect. One electron pushes another, which pushes another, and so on, until the electricity reaches your home. Electricity is an invisible phenomenon. We can't see it, but we can measure it. Power, which is measured in watts, depends on two phenomena: voltage and current. To give an analogy, voltage is like the speed at which a car is being driven on a highway. Voltage is measured in volts. Current can be compared to the number of cars driving past a milestone on a highway at the same time. Current is measured in amperes. If you combine voltage and current, you get power, expressed in watts. Power can be compared to a highway's capacity to handle various numbers of cars. And if we measure how many cars have driven on the highway in an hour, we get the energy consumed. Energy is the amount of power consumed during a given time. Let's take another example. The power of a 25-watt compact fluorescent bulb corresponds to its ability to provide light. If that bulb remained lit for 4 hours, it would consume 100 watt-hours in energy. After 40 hours, the total consumption would be 1,000 watt-hours, or 1 kilowatt-hour. More than ever, electricity is a precious source of energy. Using energy-efficient products like compact fluorescent bulbs is a good way to reduce consumption. There are many ways we can change our behavior or habits to save energy. Every little bit helps. Making wise use of energy is good for all of us and good for the environment.